Okay, time's 12:30. So let's begin. So at the end of class, we will, well, I should say end of class, but at 1:20 we will discuss assignment number 1 and also assignment number 2. Today we will continue looking at the finer points of the data set while we go through the lecture notes. Are there any questions before we begin? Okay, so we left off last time on approximately page 6. Okay, so we were talking about this place-kicking data set, and we need to reformulate some of the variables and actually create some new variables in order to get it to a form that one could actually use for a data analysis. Now, obviously, we're not doing a data analysis in this, or a formal data analysis in this class, but we can talk about some of these concepts because they are of getting the data in the correct form, because this is going to happen with most any kind of data set that you get if it's, if you're involved with it shortly after the data is collected. Unfortunately, oftentimes in a classroom situation, we see the data after it's been put in the nice form already. But very often in the real world, outside of this class, in an actual job, you will be faced with situations like this. Okay, so we just got done. We just started talking about the change variable. I believe we mentioned it briefly before. And what change is trying to do is measure, basically kind of a measure of pressure. Okay, so change is equal to 1 if the place kick that's being attempted would cause a lead change in the game, if successful. So for example, if the score was, let's see, suppose the score was 9-10, let me get a red pen here, and the team with 9 points was attempting a 3-point field goal. Well, if successful, the game would be 12-10. The score will be 12-10, and thus a lead change occurred. So also, if the score was 7-10, the 3-point field goal would cause a lead change again. Now, instead of the team with 7 points being behind, now they are actually tied. There are 2 types of place kicks. There are these 3-point field goals and then 1-point PATs. And so what I'd like to start off talking about next is, well, how can we create this new variable, which we're going to call change, to represent the scenarios that we want it to. So I'm going to come back over here to my SAS program then. Let me make this a little bit bigger. And let me run some of the preliminary code here. Okay. So I have my data in a data set called place kick. And again, how do I get there? What's a quick way to see it? And I can click on libraries, find my work library, and find this place kick 2 data set. And there's my data set there. I know it's a little small, but I think you'll be able to get the point. The 2 of the main variables in this data set that are most important to me is SC_team and SC_opponent. It's the score of the team that's kicking the place kick and the score of the team or the opponent, you could say, at the time the place kick is attempted. So the very first observation in the data set has 0 and 0, meaning the game's tied. Now the PAT variable represents, is this a field goal or a PAT? Y for PAT would mean, yes, it is this 1-point kind of kick. And N means no, meaning is this a 3-point field goal. Those are going to be the key aspects that we're going to look at here. Okay, so I'm going to create a new data set called placekick3 that's going to contain all my previous variables plus this new one that denotes the change in score, the change variable. The first thing I'm going to do is find then the difference in score. So I just take the score of the team that's kicking minus the score of the opponent. Then I'm going to set change to be equal to 0. So right now in my data set, with that line there, all my observations, all 1,400 observations are going to have a change equals 0. But in certain situations, I'm going to change it to a 1. So if the PAT is equal to y, meaning, yes, this is the 1-point kick, then, if PAT equal y, and the difference in scores between -1 and 0, this is a lead change place kick, so change is equal to 1. Also, if it's a field goal and the difference in scores between -3 and 0, then change has to be 1 as well. Okay? So, I had a few different scenarios here I had to look at, and the trick was, okay, set change to be 0 first, and then pick off those two basic scenarios to make the corresponding changes. So I can run this. I can do a proc print to get an initial check to see if I did it right. So again, the first observation, the score was 0 to 0. Difference of score is 0, of course. It was a field goal, so change has to be 1. The next observation, the score of the game was 3 to 7. Difference of score is -4. And in fact, in this scenario, it doesn't matter if it was a field goal or not because change would have to be equal to 0. Any questions? So here I'm only printing the first 20 observations. What would be another way that one could check to make sure that all 1,400 observations were done correctly, other than looking at all 1,400 observations? What's another procedure maybe that we could use to look at everything at the same time? Maybe to summarize everything at the same time. Proc builder? No. I thought it was going to be funnier than it was. But no. What's that?
One of the tables.
Yeah, I want to construct a table, but what procedure is going to construct the table for me? Like I want to construct a contingency table. What's the procedure's name? Freak? Proc freak, yeah. So I can go proc freak, then what? Data equal placekick3. Okay, what's my statement that I need to create a contingency table? Tables. And let's see now. How about we put difference in score, asterisk, PAT, and here's something that we haven't done before. I'm going to put another asterisk and then a variable. So now I have a three-dimensional table that I'm going to create, you could say. Now in these situations, and this was brought up in the notes even though we didn't talk about it in class, it's often helpful to use a option after it called list. Because instead of constructing these tables where you have rows and columns, in this case we'll also have strata for the third dimension, instead it's just going to list out all the combinations together. And I'm going to just put a whole bunch of options here to make it look a little prettier. I'm going to run it. Let's see what happens. Okay. So again, we're looking to see that what we did in that data set is give us the correct version of change. So when we look at the difference in score, PAT, change, and frequency. So frequency means there was one time that the difference in score was 35 points. And yes, a PAT was attempted, and the change variable was 0, as we would expect. Okay, because it's not a lead change place kick. Just because you get 1 point, it's not going to really affect fact, probably the whole outcome of the data. And so, if we look at all the difference in scores, all these big, I guess you could say, in negative way numbers, are not meaningful to us. It's only once we get to the -3s that it's meaningful, because field goals are worth 3 points. Let's also come down to here. Once a team is ahead by at least 1 point, then again, change is going to have to be 0 for all of them. Because you can't have a lead change place. If you're kicking the ball, you're already ahead. It's not going to change who's winning. And so all the positive difference in scores are not meaningful, or well, it's meaningful in terms of, notice change is always 0. Again, these are the frequencies that these occur in the data set. What's really of interest, though, just to make sure that we are doing everything right, is to look at these -3s all the way to 0s. So, for example, -3, it's a field goal. 53 times this occurs, and yes, change should be a 1, because this is going to cause, if successful, the game is going to be tied. -3, it's a PAT. Change should be a 0, because PAT is worth only 1 point. It's not going to cause a lead change. And so things are looking good for us. I don't see stuff that shouldn't happen. Let's look at 0. If the game's tied, it's a field goal, change is 1. And you can look at the other combinations too, and every single time we get what we would what should happen. And what will be an example of a case where something's not going right? Well, let's say that we have a 0 here, so it's a tied game. It's a field goal, and let's say change is 0, and I have a positive count over here. Then that's an example of, okay, things are not going right. I didn't do my coding correct. And so checks like this are extremely helpful to make sure that what you expect is actually occurring. Are there any questions? Okay, let's move on. Just some additional notes here. There may be instances where you have an if, then, and you want a number of things to happen after that when that condition is satisfied, that if condition is satisfied. So far we've only talked about one thing that happens, like change is equal to 1 or change is equal to 0. But suppose you had multiple things that you want to have happen. This is how you do it. You use a do statement and you end it with a end statement. So now, not just in this, if you remember, we had field equal G for it's a grass field, and we were creating a binary numerical variable to represent it called field 1. It's going to be equal to a 1 if it's grass, 0 otherwise. And so let's say you had some kind of second command that needs to be done when field is equal to G. Right? You can put that second command there, whatever it would be, and there you go. You can close it and the do ends. Then I also have else field 1 equals 0 there. So here's a question for you. So I have this new variable in my data set called second command equal y. Well, it's equal to y when field is equal to G. What is second command equal to otherwise? So what would it look like in my data set? You're going to probably see some second commands equal to y, but the second command is going to actually be a whole column in my data set because it's a new variable.
Well, you have missing values with periods?
Yeah, so you'll just have missing values with the periods. So we also looked at last time a case where you had nested if-then else statements. And this is helpful in situations where you have multiple criteria that have to be satisfied and they're dependent on a previous criteria, for example. And you can do a lot of different nested if-then else's. We did basically a two-tier sequence, you could say. But after a while, though, it becomes maybe even kind of unreadable or hard to read the code when you have all these if-then else statements. And so in those particular cases, you can use what's called a select when statement. I'm not going to go over it in our class, or at least right now to save time, but there's an example in the program, and please take a look at that. Okay, let's move on to page 7. Reorganizing data. Note they changed there. Changed the horizontals to verticals. Not sure what happened there. Anyway, so maybe one of the toughest things to using SAS is to get the data set in a correct form so that you can use it with a proc. We kind of were doing that with a place-kicking data set, but I think this is going a step further where you really need to reorganize it so that a procedure can use a particular data set. And there's a good example of when this occurs in the GPA_graphics.SAS program that was taken a look at in the last section, where what we needed to do, or the purpose was, I didn't go over this in class, what we needed to do was construct some box plots, where I want to do a box plot that compares college GPAs to high school GPAs. And due to the form that the data was already in, and you can't use the proc SGplot to do it immediately, unlike what we had with the serial data. That's why I did the serial data in class already. So this next example shows how we can use vertical concatenation to get the data in the correct form. So in other words, just in general, let's say I have a data set here that has 3 variables. So this is my little graphic representing, let's say, a data set. The very top line, those lines there represent variable names. And then below it, the little squigglies are the actual data values. Okay. Suppose you have one data set like that. And then you have another data set that has exactly the same variables with exactly the same names. It doesn't have to have the same number of observations. And what vertical concatenation means is I'm going to take this and put it right below it. That's the main goal of this example, to show you how to do that. Okay. So let me... And let me get my data set back in again. Let's see. Okay. So my data right now looks like this. I have a column for high school GPA, I have a column for college GPA, I have 20 observations in total. What I would like to do is reconstruct the data set, reorganize it so it looks like this. Again, the reason is so that I can get proc SGplot to do our box plots. Where I have school now as a variable, and it's either going to be high school or college. And then I have GPA as a variable that has the individual's corresponding GPA. So this 3.04 high school GPA is for the same person who has a 3.1 college GPA. It's just a reorganization of the data. So how can I do that? So this is probably, right, definitely the most complicated use of data sets that we've seen so far. So I'm going to use a data set first, where I'm going to create 2 new data sets at the same time based upon my original data that was in set 1, where the first data set is going to have just the high school GPAs. That's it. The second data set is going to have just the college GPAs. That's it. So here's a nice, efficient way to do this. If you want to create more than one data set at a time with a data set, you put both, or put all the data set names that you're creating up in the data line, and then immediately I want to drop the college GPAs. Immediately I want to drop the high school GPAs from those corresponding data sets. So when I execute this code, I come back over here to my work library. I find the data set. We'll just look at high school. Notice I just have high school GPA set. If I didn't have that drop statement, what do you think would have happened? So if I didn't have this drop statement, I'll just answer it for you. Basically, it would have been an exact duplication of what set 1 was. Okay. Next, I need to get both these new data sets in a form that I can then use for vertical concatenation. And so to do that, I'm going to create a new data set based upon the high school set. But notice what I have here. Data, high school set. Remember, this data set just creates an actual physical file on your hard drive. So all I'm doing here is I'm just writing over the previous file that had exactly the same name. That's it. So it's okay to use exactly the same name. Then I'm going to rename what was HS before, which was all the high school GPAs. I'm going to call it GPA. And then I'm going to create a new variable that's exactly the same for every observation called school. It's going to have a value of HS. So if I run that, there's my new version of the data set. I can do exactly the same thing then with the column set. Essentially the same thing. So now here comes the vertical concatenation. Simply, I'm going to create a new data set called set2 for the lack of a better name. I'm going to put college set in there first, and then right below it, I'm going to put high school set. And there is the new data set. Any questions? So now I can go to proc sgplot. And actually the second one's better, so I'm going to just use the second one here. So data's in set 2, vertical boxes. I could have done H box for horizontal box. Just because I'm using vertical box has nothing to do with the fact that I have vertical concatenation of the data. The variable is GPA, that has the actual numerical values, and I'm going to create categories based upon school, high school or college. Put a nice little x-axis label on it, and here we go. So you can see that the high school and college GPAs are very similar. The big difference is what? High school GPAs have more variability. Why does that occur?
Because you can get 5.0 in college.
Yeah. But in high school classes, you can have a higher GPA than a 4.0 if you're taking like AP courses. So that's why you see that. Okay, are there any questions? Okay, so that takes us to page 9. So now we have another common thing that you will need to do in SAS to get the data into a form that you can use with the procedure. And this is creating multiple data sets from one data set. Well, we essentially just did that, but here's a more general way to do this. And before I get into this, I'll just say, I think getting the data into its correct form is not necessarily the most interesting thing in the world, but it's extremely, extremely useful. Okay, so the most general way to create multiple data sets for one data step is to use the output statement. Okay. What I would like to do as an example, and note that there's this very small typo there. Instead of obs equal 5, it should have been 11. It's small. What I would like to do first, and this was all done in order to do a plot in my serial program. What I would like to do first is with the serial data set, create 4 separate data sets based upon the shelf. that the serial comes from. Okay. Let me get my data set back in. There we go. It's not too difficult. I want to create 4 data sets for the 4 shelves. So again, notice in the data line, I have 4 data set names, shelf 1 through shelf 4. It's going to be based upon set 1, which has the adjust serial data. And then simply, I use an if-then statement. If shelf is equal to 1, then output into a new data set called shelf 1. I do that with the other data sets as well, or with the other shelves. Let's check the log window. Notice it says all these 4 data sets have been created. It says how many observations are in each of them, so it makes me think, yes, I did do it right. Let's look at shelf 1. And indeed, those are the shelf 1s. Okay, well, here's a question for you. Let's say I have a situation where not only do I want to put the data into shelf 1, in this data set called shelf 1, perhaps also I want to do some stuff with some of the variables in that data set before shelf 1 is fully created. And so that shelf 1 maybe contains some additional variables. What could I do? How could I change this code? The hint is where my cursor is, I would start typing there. We actually talked about 5 or 10 minutes ago. Or a certain command that you can make, or a certain statement that you can make to do stuff like this. To do stuff. Do, yes. So I could do, and then let's say, I'm just going to make this really simple. Temp equal 1, I'm just making something up here, and we'll say var1 equal young. Okay? And then I'm going to need to still output everything. I need to end with an end. Let's see what happens. So let's find shelf 1. And look at that. Towards the end there, I got those new variables created. So you can do those kinds of calculations within this one data step. Let's say, bring back to what we had before here. Suppose I would run this code right now. Why would SAS say there's a problem? I'm not trying to ask a trick question here. I'm just trying to get you used to using SAS here. Key thing is right there. It's open. So, let's see what happens. I cannot do anything with it because the data set's open. And this, especially for new users of SAS, this can be frustrating because you're like, what's wrong with my code? There shouldn't be anything wrong with it. Well, this is just annoying. You got to close it out before you can run it. And I don't know how many times while I'm using SAS, I want to do a data set. I immediately go look at the data set that's in the Explorer window over here. And then, oh, I didn't get it right, so I'm going to make a little change to my code. I run it, it's like, oh, I forgot to close out the data set too. It's kind of a waste of time. That SAS makes it occur. So, okay, now that I have these 4 data sets, I want to also show you something else that's common in SAS. And that is, let's say you want to do not vertical concatenation, but horizontal concatenation. Meaning, let's say that I have 2 data sets. They don't have to have the same variables, but they need to have exactly the same number of observations. What I want to do now is I want to combine them into one data set. So in other words, I'm going to join these two data sets together. And for my example here, I'm going to do this with shelf 1, shelf 2, shelf 3, and shelf 4, those data sets. So to do the horizontal concatenation, I have to introduce you to a new statement in SAS. It is called merge. Okay? So, come back over here. So I'm creating a new data set called set2. Notice I no longer have a set statement anymore. The merge takes the place of it. And I'm going to merge shelf 1, shelf 2, shelf 3, shelf 4 all together. Now the key thing that I have to change though in all those data sets is the fact that they have the same variable names. So because of that, that's going to cause me to say, okay, for sugar, change it to sugar 1 for shelf 1. For fat, change it to fat 1. I do a similar thing for shelf 2 through shelf 4. Also, how about we just look at sugar and fat itself? So I'm going to keep them. And so this is a nice illustration too, how with these parentheses, with the data set such as this, you can control what's actually going into the data step. In fact, these parentheses then would work too if you were to use, let's say, a proc princ or proc reg or whatever like that. It's a quick, shortcut way to make changes to the data set on the fly without doing a formal data step just to make those changes. So let me run this. So if I look at set 2, you can see I got what I want. Now, the purpose of doing this, as you will see my program, was so that I could do a plot in SAS. This plot involved proc gplot. Obviously, we skipped the G procedures. So you're not responsible for the G procedures. You're not responsible for the actually doing that particular plot. But you are responsible for understanding how I got the data in this form. Now, where's an example, where's another example where this kind of data changes or reconfiguration is helpful? An example involves if you have repeated measures data. Does anyone know what repeated measures data is? It's fine. Let's say that you are getting multiple measurements on the same person. Let's say you're giving a new drug to a person, and at time 1, 2, 3, and 4, you're measuring some characteristic about them. Maybe you're taking blood specimens, you're measuring, let's say, maybe the something with respect to the blood over time. So you're taking repeated measurements on the same observational unit. Let's call it experimental data. And so you can imagine a situation where you have the sugar 1, let's say, the time 1 response, the sugar 2, the time 2 response, and so on. And depending upon how the data was originally structured, you might have to perform the exact same thing that I just did here to get it into a format where every row represents a person. Very often when you're using particular SAS props, you need to do that when you're dealing with repeated measures data. We'll look at another way to reformulate a data set like this shortly. Any questions? Okay, page 11. Merge data sets by a variable. So we just talked about merge, and basically that was used for simple horizontal concatenation of two data sets side by side. But sometimes, imagine a scenario, let's say that you're working for a company, and you have two big databases of that involves your customers, where one customer can appear in both databases. Sometimes they're only in one database. And for some reason, you may want to somehow put these databases together and have each row correspond to the same individual. So you want to merge by maybe some unique key or unique identifier. This is where merge can be taken a step further to do that. So I have a very simple example to illustrate this. Let's say I have two data sets, set 1, set 2. And they're so small, I'm just going to enter them in line by line inside of SAS. So I'm using the data line statement. Notice my input, I have two variables, name and response 1 or name and response 2. Why do I have to put a $sign here? Does anyone remember why?
Not numerical.
Yeah, so name is not a numerical variable. So because of that, I always have to put a $sign after it when I'm doing like a data step like this. You know, if you're using a non-numerical variable like in a proc, like proc means, you don't need it. It's only when you're basically getting the data. And now notice here, both data sets have the name variable. And this data set has one observation with an A. This data set has two observations with an A. This data set has an F for value. This data set does not. Okay. Now what I'm going to do next is merge these two data sets together by name. So simply create a new data set called merge_set1 for lack of a better name. Notice I don't have a set statement again. I have just a merge statement. I put the two data sets here I want to merge together. How do I want to merge them? By name. So let's go ahead and run that and see what happens. And here we go. So remember, there was two A's in the second data set, one A in the first data set. Look how SAS reacted here. You have two rows corresponding to A. The values or the response in that second data set was 10 and 11, and SAS repeated the response from the first data set. Also remember how there wasn't an F in that second data set, but there was in the first data set. Look how SAS reacted. We put a period there in that for response 2. Now there's many other ways to do merges. This is just a very basic one here. On your own, you're welcome to take a look at all the things that you can do with it. But I think, at least for our class, I think this is sufficient for what you can do with a merge statement. Any questions? Okay, page 12 then. All of you know what transposing a matrix means? Well, you can also transpose a data set. Excuse me. So when you transpose a matrix, the rows become the columns become the rows. Well, at times you may want to do something very similarly when you're working with a data set. And in particular, this happens when you have repeated measures data. So the procedure in SAS that actually does that is called proc transpose. Let's actually take a look at an example of where I have found this to be helpful in the past. So this is from an actual problem that I worked on a number of years ago. Was I made up the data because I can't use the exact same data that I did use. But what we were doing was it was a phase 1 clinical trial where we were examining the safety of a particular new drug that was being developed to treat schizophrenia. And this was the second phase 1 clinical trial that was done on this new drug. And we had healthy male volunteers, and they were given either 0, 3, up to 72 milligrams of the drug. We wanted to see how much could the body take without side effects occurring. And a number of measurements were taken on these people at time point 0, like right before they were given the drug, time 1, all the way up to time 4 hours post-drug taking. And one of the measurements that we're going to, or the measurement that we're going to talk about, is a psychometric test called the Continuous Performance Test, or CPT for short. And at these times, this test was administered, and this is how it worked. A subject would sit in front of a computer screen, and randomly generated numbers would appear one every second for 480 seconds. Every time that subject saw a 0 appear, they had a button, and they were supposed to press it. And so what we were trying to measure was how many hits, or how many times did they get it right. So there was always the same number of zeros that appeared every single time, just not necessarily at the exact same time. But we were always measuring the number of hits. So why is this important? Well, let's say that this drug maybe causes or potentially induces drowsiness, or maybe double vision. Well, then you would expect their hits to go down after they've taken the drug. So that's why this particular test was so important. And so we were always measuring then a comparison to baseline, which is what time 0 is. Let's take time 0 hits minus time 1 hits. And let's say it's a positive 9. So what that means is time 1 is less than time 0. And this is what we were thinking would maybe occur. The number of hits would go down after the drug was administered. Okay, so this is my data, or this is the background behind it. Close some stuff out. Okay, just to change things up a little bit, my data is in a permanent SAS data set. And when I was actually working on this, I purposely, a number of years ago, I purposely did this because I've taken out a lot of the stuff in terms of getting the data into a form that I needed to use. There was a lot to it, so that's why I decided to create a permanent SAS data set that I could always work off of. And so to use this permanent SAS data set, the first thing I need to do is create a library. And again, all the library is a pointer, you could say, to a physical location on your hard drive where this SAS data set already exists. So I decided to call it a library called Chris, again for the lack of a better name. This is the actual location of my hard drive. Then I often do this, you don't necessarily have to do this, but I often do this, is that whenever I have a permanent SAS data set, such as chris.cpt, I put it into my work, I put a copy of it in my work library. So let's go ahead and take a look at it. And this is what we have. So patient 101, we have time 1 through 4. The change in hits from time point 0 is located right here. That person was in a dosage group of 0. Okay. Now, in order to use particular SAS procedures with this repeated measures data, I at times needed to transpose the data so that instead of one person being represented by 4 rows, I need a person to be represented by just 1 row in the data. So in other words, I need to take this right here and basically create 4 variables that has my change in hits at time 1, 2, 3, and 4. So that now this person is just represented by 1 row. I'm going to do the same thing for this person as well, and so on. So if you notice here, what I'm doing is I'm transposing by patient. I also have, in my notes here, I just noticed this. I also have, I'm transposing by patient and dose. I have a feeling I can do it without the dose there. We will see. But let's assume for now that I need to transpose by patient and dose. And so to do that, I need to get my data in the correct order. So I need to sort it first. And notice here when I use this new procedure proc transpose, I have a by there. And we've seen that before, like with means. And what do we have to do? We have to actually sort the data first. And this is common in any SAS procedure. Whenever you have a by statement, you always need to sort by those variables first. And so to use this proc transpose then, I'm going to base upon set 1. I'm going to create a new data set called set 2. The variable that I'm going to transpose is C_hits, the change in hits. And so now what this is going to do is give me 4 new variables, time point 1, 2, 3, and 4. And as a prefix to those variable names, I'm going to put the word time. So you're going to actually see new variables called time 1, time 2, time 3, and time 4. Let's actually run this and see what happens. And here we go. Patient 101 is now just one row. Time 1, -9. Time 2, -11, and so on. Now you also notice, now I guess this wasn't a big deal, but I did put it here. Name equal response. I used that as a particular option. All that did was, I come over here to name a former variable, column attributes. You have a name or response. I just decided to do that, I guess when I was writing the lecture notes, maybe just to be cleaner. Really, in the end, this is just a descriptive label, you could say, of what did we just transpose. And in the end, I probably would just simply drop that out of my data set. Just out of curiosity, what would have happened if we did not do that? Yeah, it still worked. So perhaps I just went too far. You don't actually need dose here. You don't need dose there because we're transposing by patient. Let me make a note to myself. Okay. Oh, now I know why. Now I know why I did that. I should have looked ahead. While we're simply just transposing by patient, I needed the dose variable to carry forward with me into the data set. Because if you notice what the data set looks like when I did it without dose, you don't see dose there. I want to keep track of dose in there. So that's why I needed it. I'm sorry. I should have looked ahead. So for example, now I'm going to sort by dose to get everything in a nice order. And then I can do a proc means with a class statement of dose. So if we take a look at the actual output, you can see for each dosage level the means. And this is probably the most important thing of this data set is these means here. So I apologize. So do you see any trends? And we're not doing a formal statistical test here. Do you see any trends?
Time 3 and 4 normally have more hits with the 36 and 72 dose.
So for these higher dosage levels, so more of the drug, we are seeing a reduction in the hits. So this could be, You know, I guess what the researchers fear, you could say, is that this is having some side effects at that high of a dosage level. In an actual practical sense, what one would hope is that maybe we can administer the drug to somebody at a lower level and still get the desired effects, so we can get away from those side effects.
How would you interpret like 9 has 32 and 19, but then 18 doesn't show much difference, and then 36 does?
That's the inherent variability of the data. And so, you know, what do we do as statisticians then? We try to determine, you know, like what we're seeing maybe down here, is this just simply due to variability, or is there truly a difference? And that's where a formal statistical inference would come into play, where we can say, well, like, with 95% confidence, yes, there is an issue. Okay? Any other questions? Okay, I think this would be a good place for us to stop the normal, our regular lecture here. Let's talk about the assignments. Okay. So, assignment number 1, all of you should have received it back since our last class. I have some comments about that, not much. So I have the answer key available for you on my course website. The reason why I like to always give an answer key with assignments and most tests is because I feel as though this is the highest amount of feedback that I can actually give you. You know, and one of the key aspects of this for you to learn from it is that even if you got a problem right, take a look at how I approached it. I could have approached it differently. You know, especially in our class when we're talking about coding, you know, my way of doing the coding could be more efficient than what you did, even if you got a full credit for a particular problem. Okay, and part of this class is figuring out how to be most efficient to get stuff done in a computer software package. So please make sure you do take a look at all parts of my answer key, even if you get a problem right. Now, in terms of actually viewing the graded comments that I give in these assignments, so since we're using Word here, when I grade, you can see where my mouse is, I track changes. My changes will be always tracked in red. If you're not seeing red changes to your document, doesn't mean that you got everything right. It means perhaps that you're not, the default viewing of Word is not to give them in red. And so you might actually be missing my comments that I make in the document if you don't make sure that they're red. How can you do that? Well, up here, we see it's on all markup. The default for Word is simple markup. Look what happens. And yes, you do have a little line here that says, oh, there was some kind of change made, but doesn't necessarily say what change it is. So if I page through here, you may miss, uh-oh, this is wrong. The comment that hopefully I would phrase it in a lot nicer way than that. This is just to illustrate that, you know, when you see something like this versus that, when it's all markup, you can see it a lot better because it's red and it's underlined. So I strongly recommend that you always turn on all markup when you look at the graded assignments that I give back to you. Okay, well, I guess I have a question for some of you then. A number of you on your assignments, whenever you had equations, you use red hats, you use, let's say, red bars for equations instead of keeping everything in black as all the numbers and text was. So could someone tell me why? You know, like for the regression model, why hat? Or why it was in black, the hat was in red? Fortunately, I know there was a number of groups that did that. Unfortunately, I don't remember which groups. So perhaps I guess you can just be silent and just not answer. Okay, well, I will tell you that you need to make sure everything is the same color. There's no reason why you need to put a hat for like y in red. Or let's say if you have a fraction, you put the bar, that does the numerator versus the denominator in red. In terms of, maybe this is just picky, but in terms of handing in something that's professional looking, don't change the color if it doesn't need to be changed. Yes?
But mine is black on my computer and it's in my screen.
Really?
Yeah.
Okay.
If you turn on the track, the color will change to red. But if you turn off the track, then it's black.
Well, I guess it doesn't make sense why. So I've never seen that ever in my years of grading Word documents. I've never seen that before. And I always track my changes in red. So are you actually right now on your computer clicking on track changes and you see it in red, and then when you do...
You turn it off and it's black.
Really? What version of Word are you using?
2016.
Oh, I'm using 2013. What version of Word?
The newest one.
Excuse me?
Yeah.
16?
Yeah.
You both have Apples?
Yes.
Do you have an Apple?
No.
PC? Well, I guess I won't take all for it now. But that is a big problem with Word if Word's doing that. That does not make any sense to me. Why that would occur.
Actually, I'm using 2015.
Oh, 2015. I'm pretty sure I'm using 2013 here. Off the top of my head, unfortunately, I don't remember exactly how to check that, but I'm sure I'm using 2013. I've been wanting to upgrade. I just haven't. I've decided to wait until I get a new computer to upgrade. Huh. Okay. Okay, I guess the only other comment that I had was the grades were very good. Almost everyone got A's. So do you have any questions regarding the assignment? Okay. It was nice to get off to a good start then for the semester. Generally speaking, to give you an idea of past experiences of my students, the assignments, let's say if you want to get an A in this course, typically need to get an A on the assignments. The tests are more difficult, or at least I don't think they're more difficult, but students, their grades are lower. And so it's if you want to get an A in the course, it's important to do very well in the assignments. Let's talk about assignment number 2. So the first 2 problems are basically continuing on from the first 2 from the 2 problems on the previous assignment. So problem number 1, first of all, I was going to give you some experience with doing plots with respect to the NFL Combine data. So first of all, this is more of a, not something new. I want you to sort the data by position. And I recommend that you look at what happens if you sort the data by position, or if you don't, with respect to the following plots that will occur. That will give you some insight to how SAS makes assignments for colors, plotting symbols, and so on. So that's actually a very important thing. It can be frustrating to figure out how SAS is doing this. And this will give you an illustration of how SAS is doing it. So, but what you turn in, I do want the stuff to be sorted by position first. Then, using that data set after everything's been sorted by position, construct side-by-side box plots of the 40-yard dash times plot for each position. to give you some experience with changing some things to go different from the default. Simply change the fill color to yellow for those box plots. So you're going to be working with the attributes. Then do side-by-side dot plots. Again, to give you experience with changing some stuff, make sure you're using red open circles for your symbols. Then D is just a simple interpretation question. Okay, given what you've just seen on these plots, interpret it. Shouldn't be difficult. Part E. I should mention, make sure you comment about all four of these: location, centrality, variability, and skewness. Now, part E here, I just want you to have some experience with a scatter plot. So create a scatter plot, the 40-yard dash time versus the bench press weight. You're going to see some trends in the data. To illustrate these trends, what I want you to do is coordinate the symbols of what's being plotted by the position. I want you to use those particular symbols for each position. So all I did was, in my answer key, I just did a little screen capture of what was the legend in my plot. Obviously, you should include a legend as well. Include grid lines on your plot, include axis labels, and then go a little bit further from what we discussed in class. I want you to label the observation on that plot, label that plotting symbol by the name of the player who, for the player that has the largest bench press value, label that plotting point on the plot with that person's name. Sorry if that was confusing how I was first saying it. We haven't discussed how to do that. And what does one do in these kinds of situations? You go to the help, or you do a web search. Well, I thought about just leaving it for you, just for you to figure it out yourself, but I decided to give you a little bit of help. My web search yielded that particular result there from the SAS website. It's not necessarily a simple process of, let's say, one little option you have to change on Proc SGPlot to get this to work. It actually takes just a few steps, and they have a nice little example of how to do it for their example data set. Basically, you need to take that or learn from that and transform it to your own data set that you're using for this problem here. So a nice example of what you will often be doing outside of this course. In terms of, you got a new problem, you need to figure out how to solve it. And then part E, describe the relationships that or the trends that you see in the plot. Number 2, continuation of this shelf life or stability testing problem, where in the, let's see, get that out. So in assignment number 1, you had Proc Reg produce this particular plot. I want you to produce this exact same plot now using Proc SGPlot. So the reason why I do that is because this is going to give you experience with using the SGPlot procedure. Remember how those SG procedures are built upon the ODS graphics that were first developed for procedures like Proc Reg. And so one should be able to reproduce it exactly. So when I'm saying exactly, like I want the exact same like labels down there in the legend. The only thing that I had a little difficulty with, and hold on a second, let me just check something so there's not a confusion later on. Okay. When I say exact, there's one part that's not exact. I don't want that part. I just want the plot. I don't want the numerical summaries. Sorry, I didn't say that before, or I didn't have that in there. But my answer key, let's see here, I don't have that extra part. I guess I'd be willing to discuss extra credit, though, if someone wanted to try to put that on the plot, too. So reproduce the spot. The thing that I had trouble with was matching the fill color there exactly. I don't know if I quite got it, but I think I'm close. And so to help you out, I say at some point you're going to want to define a particular color for that fill color, and that's the color that I want you to use in a hexadecimal RGB specification. Take a look at the help for understanding colors in SAS, and you're going to see there's a variety of different ways to specify colors. This is just one way. Then in part B, continuing the plot in A, use two new statements that we haven't discussed in class. Use one of two new statements. The drop line statement or the ref line statement to draw on the plot, at least what I had previously done by just drawing it in Word. So I want you to draw that line at 0.95 and then drop it down to where that shelf life should be. I want you to do that all in SAS. So that's problem number 2. Are there any questions? Then lastly, problem number 3. An old-fashioned way to find quantiles from a t-distribution is to obtain them from a table of values. So typically these tables, you've all seen them before, so you might have degrees of freedom on the rows. This is for a t-distribution. And on the columns, you have probabilities. Oh, let's see, 0.9, 0.95, 0.975, 0.99. And then inside the table, you have cells that represent, for example, the 0.9 quantile from a t-distribution with 1 degree of freedom, or the 0.95 quantile for a t-distribution with 1 degree of freedom, and so on. I want you in SAS to create this t-table. Now, how to do that? Well, we haven't got to that part of the lecture notes yet. That will be basically the stuff that we talk about on the first day. So you're going to be creating your own little t-table. That's assignment number 2. It is due September 23rd at noon. And again, you can work in pairs if you would like. Are there any questions? Yes?
Learn more maybe about how the exam looks compared to the assignments. Does the assignments take some time looking through help and with an hour 15 for the exam? How can we use assignments to study as we look forward?
Well, I mean, use obviously the lecture notes and the assignments. And, you need to get to a level of being comfortable with finding that stuff quickly, obviously. So there is to some respect when you're studying is that you can't take 10 minutes to try to find something. You need to know where to look. You need to be very familiar with my SAS programs that will be available to you for the test, so that if I ask you to do a box plot, you say, oh yeah, that was in Chris's serial_graphics.sas program. I can get his code little segment and quickly insert in my own code. But yeah, I mean, obviously time is of an issue. The tests will be shorter than what you see in these assignments, and not everything will actually be computers. So I might ask you a question, like what we talked about today. I might ask you some short answer questions, such as a very simple one would be, how does SAS denote missing values in a data set? Okay, that, just tap your pencil once, and there you go. But there might be more complex questions where you have to maybe write a few sentences. Okay. Any other questions? Okay, then that's it for today.